All right, so in chapter 9, you were introduced to three-dimensional coordinate systems, and uh, you know about the dot product, cross product planes, and so forth. And now in chapter 10, we work with vector functions. Vector functions. So in this problem here, section 10.1, we work with vector functions in space curves. Space curves. So what we want to do here is we want to describe and sketch the space curve defined by this vector equation. You have an x component, but now that x component's a function of time t, or a parameter t. You have a y component, and you have a z component. Okay, and I want to make a note about something. So you have the vector equation here. But you also can describe the vector equation this way, simply by stating the components. And what are these equations here called? What are those equations called? Give you a hint. It begins with a P. Good. Parametric equations. Good, Jamal. So parametric equations, I mean, you're used to seeing parametric equations in two-dimensional space, like if you want to trace out a circle or something in two-dimensional space. But in three-dimensional space, we need three parametric equations, an x, a y, and a z. Now, we have to think, what does this space curve, what does it look like? What does it look like? I notice there's a cosine and a sine in the space for two components of the space curve. What might that tell you about the behavior of the space curve? How it's traveling as t grows? Spiraling. Good. Good, Ryan. Good, Ryan. Both Ryans. There's spiraling going on here. Okay. There's spiraling that's gonna go on. And in fact, if I bring up example 4 from the book, may I go to the textbook, to the ebook? Does everybody have this example copied down okay? All right, good. Let me bring up the ebook. One moment. Got to go back in here and get it. Okay, I'll go back in here. Okay, so example 4, same one we're working on. Sketch the curve whose vector equation is given by that vector equation, r of t. R of t equals cosine t times the vector I plus the sine of t times the vector j plus t times the vector k. And they note here that here are your parametric equations, and of course x squared plus y squared equals cosine squared plus sine squared, and that equals 1. So, you know, that means that the curve has to lie on the circular cylinder, x squared plus y squared equals 1. I mean, the x component and the y component of the space curve are such that the square, if you, x squared plus y squared equals 1. Okay, so the z, the z equals t determines the space curve going up or down. But the space curve is going to have to lie on circular cylinder. It's going to have to lie on that cylinder. So this is a helix. This is a helix. The x and y components of this vector equation control the spiraling, going the circular motion, but it's spiraling up because, I mean, as t increases, you have circular motion due to the x and y components of the space curve. But at the same time, the z component of the space curve, t, it increases. So that means the space curve is spiraling upward. And so you get this space curve, which is a helix. Are there any questions on that? All right. Well, now we can use MATLAB to help us graph this space curve. So let me show you how we'll do that. All right, let me go off of here. All right, one moment. So if you go into your Blackboard, and I'll bring it up here. Let me see. Share application. Okay, you all can see the Blackboard okay? Maybe give me a few thumbs up if you're seeing the Blackboard page okay. Okay, thank you. All right, so where you go is MATLAB Programs. Click here to see the MATLAB Programs. And we go to section 10.1. 10.1, there's a MATLAB program that'll help you draw space curves. You click on that link, and it should download the program onto your computer, the MATLAB program. And assuming you have MATLAB installed, which I think probably everybody does now, if you click on the MATLAB program, it'll bring up MATLAB. Okay, so I'm getting MATLAB brought up on my computer. All right, and let me go into MATLAB here. Okay, so here is the let me see. Hold on. Let's make sure you're seeing what I'm seeing. Yep. Okay. There's the command. It's called EasyPlot3. Why do you think the 3's there for EasyPlot? EasyPlot3. Because there's an EasyPlot also in my in MATLAB, but this is EasyPlot3. Three-dimensional. Good, Eric. Good. Good, Eric. It defines it as 3D. So this is a way to get a quick graph of a space curve. You use, first of all, you have to symbolically define your parameter t. That's sims t. And then EasyPlot3. And now you put in your, you have your components. You have your components here. And then I'm going to have t go from 0 to 4 pi and skip by pi. Okay, maybe that's too big of a skip factor, but let's just so I copy and I paste it on the command line and I hit enter and it should produce a space curve. Okay, so let me bring that up, and you're trying it too, I trust. Okay, and there's your space curve. How many think that's pretty cool? Yeah. Deodath likes it, Christopher, John. And put it in blue. You can control. Ryan likes it. Thank you, Ryan. Thank you, everybody. You can control your the color. You'd have to investigate a little bit. If you go in on Google and type space curve examples, you'll see different examples. But I just wanted to do something easy. And look at the axes. Now the axes are kind of interesting. You notice the axes. The x-axis and the y-axis and the z-axis are going the right direction. But what's interesting about the axes, the numbers on the axes? Well, the domain's okay. The domain's okay. You're between -1 and 1. I mean, look at the x-axis. When you're going forward on the x-axis, you should be going in the positive direction. But what is the graph showing you? What is the graph showing you? As you move in the positive direction, look at the scale. Look at the numbers on the x-axis. Yes, so going from the origin forward, the numbers, are they positive or negative? Let me show you what I mean here. Hold on. I'll show you what I mean. Okay. One moment. I'll just. Okay, so let's focus on the x-axis. I'm going to draw some notches here. Well, I can do a little better than that, right? Okay, give me a number to put on this first notch. Give me a nice number. Okay, well, but shouldn't it be a 1? Aren't we used to our x-axis, like, I should probably put a little bit, like, aren't the numbers that way positive? And then the numbers here, give me some numbers here. And I appreciate all responses. Some nice numbers. -1, -2. So, you know, I'm just focused on the x-axis. So normally the x-axis, when I'm going, you know, in this direction, I'm used to numbers increasing in this direction, you know. But if I go to the picture here, looking at the graph, look at the x-axis. Okay, I mean the origin is here, right? But in the center. But do the numbers seem to be increasing, moving forward on that x-axis, or decreasing? Decreasing. And if you notice, if you compare this, that's right. If you compare this helix to the helix in figure 2 from example 4, it's like backwards because the axes are backwards. You see that the axis is backwards for the y, also not for the z, not for the z-axis, but for the y-axis. The orientations, the y-axis is going like in the right way, but as you see how it's backwards? Okay, so you can fix, yes, thank you, Marvelous. So you can fix this. You can fix this by going to Tools. There's a thing for Rotate 3D. 3D. You can it takes a little bit of work, but you can get it. Well, you see what I'm trying to do, right? Hey, I'm loving it. How about that, huh? There we go. You see? How many like that? A little adjustment. And this MATLAB graph looks the same as figure 2 graph from example 4. Okay, you just go to Tools and click Rotate 3D. And there's a lot of things you can do. A lot of things you can do. How many are trying the rotate feature right now at your home? How many of you are trying it? Trying to get it to look like that? Okay, John, it takes a little, you know, it's all in the wrist, you know. I love it though. I mean, normally it takes me a while, but I just, you know, hey, you know. All right, so there you go. So you can use MATLAB to help you graph space curves. And what we'll do is we will continue section 10.1 on, we'll continue with it on Thursday's class. We will have class Thursday. And then we'll also talk about section 10.2 on Thursday. So it's going to be a busy day. But I want to talk about the exam, but are there any questions? May I stop the recording? We're good? Maybe who's feeling good? Maybe give me a few thumbs up. That way the recording will look good. All right, good. Diodot's good. Everybody. All right, let me stop there.